Hello everyone and welcome back. In this episode, as you can see, we are implementing our spatial grid data structure to optimize our performance. And our result will be this. You can see now in our web browser, you can see all the cells which have some bodies in it, and only the bodies in the cells are checked against neighbor bodies in the cells. All right, then let's jump to the code and let's implement that, right? Good, back to Visual Studio. Oh, and I forgot, I of course need to open my current browser. There we go. All right, this is our last state we only did the bounding boxes here. Now we are doing the grids. Okay, then let's go to the code again. And I'm gonna create a new class. And I'm gonna create a new folder. And this will be optimizations. And here, first, I'm gonna move the bounding box into the optimizations folder. All right. Then, of course, we need to change the path of the script. This is, where is it? There we go. Here we need to change it to optimizations, bounding box, and the same for our new class. And this will be spatial grid.js. Okay. Right, and then we can create our class. This will be spatial grid. And here we're gonna have a constructor and some parameters. Well, actually just one parameter, and this will be the cell size, which we specify by our own, and we're gonna set this one to the variable. So this cell size is equal to cell size. Then we have our array of cells, right? So that's our array of cells. And then we have our mapping, rigid bodies to cells. All right. Then we have some methods. First, initialize. Here I'm gonna pass the world size and all the rigid bodies, which are well, actually, it's gonna be the array of the rigid bodies. So if we're gonna add more rigid bodies, it's going to easily add it to the array. Yeah, then we can set list.world size is equals to world size list.rigid bodies is rigid bodies. Then we are calculating the cell count for the x direction and for the y direction. We can do that by saying we have the world size, all right, in the x and the y direction, and we're just gonna divide it by cell size, and then we have the cell count, how many cells are there actually in x and in y direction. So this dot cell count x is equals to, and I'm gonna use parse int, is equal to this dot world size. dot x divided by this dot cell size. Same thing for y. This dot cell count y is equals to parse int this dot world size y divided by this dot cell size. All right. One thing to note, in the presentation I did, in the explanation, we saw that I had a small offset on the really right side. There was a cell, but not really fully displayed. And we might have the same problem here if our canvas is a little bit bigger than than our division. Okay, there might be some leftover, and we are gonna tackle this problem by saying if this dot cell size times this dot cell count is less than this dot world size dot x. So for example, if the cell size, no, let's say our world size is 850, all right? This is our world size. And then we're gonna and then we can say our cell size is 100. And this is just an example what I mean with that if statement. If our cell size is 100, so our cell count is 850 divided by 100, all right, which is 8.5, which is 8. So our cell count is 8. Okay, but there's still a leftover. There are still 50 pixels which are not covered by cells. And we can check this by multiplying the cell size. So what we're going to do with this if here is we're going to say 100 times the cell count, this is 8. And if that's smaller than this dot world size, or if it's smaller than 850, which in this case it is, this one is 800. 800 is smaller than 50, so we're gonna add one cell to our cell count. And that's what we're doing here. Okay, we're gonna do that for x and for y. So this dot cell count x plus plus, and then the exact same thing for y. I'm gonna copy that and say this dot cell count y, world size dot y. I think, yeah, because we need to change this one too. And yeah, now we have our world covered in cells. Then we're gonna initialize our cells. Every cell will have an array, which holds the indices. No, actually the rigid bodies, sorry. Yeah. Okay, so let's do that too. We have a for loop with, yeah, we're gonna just iterate through our whole array, and this will be cell count x and cell count y. This array is one dimensional. There's a total of cell count x times cell count y cells. So we're gonna multiply this, and then we're gonna iterate through that. And here you can say this dot cells at position I is equals to a new array. All right. And now maybe we can say console.log this dot cells dot length plus cells instantiated. There we go. Now we know also how many cells we actually created. Okay. Then we have another method, and this method will be refresh grid. And the refresh grid method is for clearing our, or let's say setting the data new again, refreshing the data basically. So this will be refresh. I'm not gonna fill it now, I'm gonna do that later. Then we have our method map bodies to cell. I'm also gonna do that later. Then we have our clear grid method. This will really clear all the data. So, well, basically, it's gonna delete all the data which is in our arrays. Yeah, this is clear grid. And then we have two more methods, which will be get neighbor, per neighbor riches. And here we're gonna say we want to have the neighbor of our rigid body. Okay. Yeah, that's basically it. We want to have the neighbor from the neighboring cells to check if there are neighbors, if there are neighbor rigid bodies, and if there are, then we can do our bounding box collision check. Then we have a draw method. Here we're going to draw our cells. And I think we can actually do this already. Yeah, we're going to implement our draw method first, so we can see something on our screen. So let's do that. This is going to be another for loop, so I'm gonna call this one this time x. X smaller than this cell count, x and x plus plus, and the same thing for the y component or for the y-axis. There we go. There we go. Cell count y, y, and then I'm going to calculate a position for our rectangle. We want to draw a rectangle for every cell. This will be a new vector 2. And this is x times this dot cell size. And we have a small offset and y times this dot cell size plus 5 because of the small offset. Then we can draw our rectangle. This will be draw utils, draw rect. Here you're going to say position and yeah, a new vector, and here I'm going to say this dot cell size minus 5, and again this dot cell size minus 5, and I'm gonna say I want to have that in gray. Okay, and this is our draw method. And I think now we can already create our cells, and they should be drawn then. Let's just first save our main HTML. Okay. All right. Then I'm gonna go to the simulation.js file, and I want to create a new grid. I think I'm gonna place it right there. So this dot grid is new spatial grid. This will be our, I think I can set it to 30 or 40, I don't know. Actually it doesn't really matter. And yeah, then I'm gonna call grid initialize with list dot world size and list dot rigid bodies. And then I can say draw. So I'm going to go to the draw method. Here I'm going to say this dot grid draw. All right. I hope that's everything we need to draw our grid. Yeah, let's go to the browser and check it out. Refresh. All right, I made a small mistake. Special grid is not defined. Simulation 8. Ah, yeah. I think I have to. Of course, I forgot to add this one. And I think I'm gonna. Let's see if it works. I'm gonna add special grid to the scripts, of course. This will be special grid. There we go. Let's go back to the browser. Refresh. Aha. Now we have draw rect. It's not a function. Okay. Where's our utils folder? Draw utils. Ah, we actually don't have a draw rect. All right. Then seems like I forgot that. Yeah, then we're gonna add this function, of course. In the draw utils, we first need to create, I think where I'm gonna put that, I guess right under the draw line. So let's say here, static draw rect. Here I'm gonna say a start. It's gonna have a size and a color. And I'm gonna say I'm just gonna copy this one, paste it in here, and I think I can just say, yeah, I need to set the stroke style, and then I can say ctx dot rectangle, and here let's the start.x, start.y, then size.x and size.y. All right, and then I hope it's working now. Sorry for this small mistakes. Okay, there we go. It's not drawing, but we don't have any errors now. Yeah, I'm gonna check why it's not drawing, and I'll be back in a minute or in a second. Actually, it's not gonna take a second. I'll be back immediately. All right, I found the error. In our draw utils, I forgot to add the stroke statement. So let's add that. Save, go back to the browser. Refresh, and there we go. There's our cell grid now. And here you can see our small, our additional cells we added. Because if you don't need to go back to the code. I'm going to show you this right now. I'm going to show you what I'm going to do if I don't have the ifs where we calculated the additional cell. Just comment the cell count x plus plus out, and now you can see there's a small gap here. And that's why we want to add one additional cell to our simulation. Okay, and another example, we can change the size of the cells. If you change the constructor of spatial grid to 50, refresh, then you can see our grid cell size will increase. And yeah, pretty cool. Okay, now we can can go back to the code and we can implement the rest of our code for spatial grids. All right. I think the next thing I want to add is the clear grid function. This is an easy one too. Here I'm going to iterate through all of the cells. So for I equals 0, and I smaller than this dot cell count x times cell count y, I plus plus, and here I'm going to reset all the cells. So cells I is equal to a new empty array. Then I'm going to sell this dot rigid bodies to cells. It's also empty array. And then I'm going to say also for our mapping for let I is equal to 0 and so on and so forth. This dot rigid bodies dot length I plus plus, and here I'm gonna add to the rigid body cells again a new empty array. Or a list, I guess it's more a kind of a list than an array. Okay, that's our clear grid. Now we can implement our refresh grid. In the refresh grid, we are going to call this dot clear grid first. Then we're going to call this dot map bodies to cell. And that's it. I think. Yeah, that's it. Cool. And the refresh grid, this is called in our update method in the simulation. So I think I'm gonna call it right between the update for the rigid bodies and the solver iterations. So right there, this dot grid dot refresh grid. All right, then we have this. And I think now we can go to how we can map the bodies to our cells. For this, I'm gonna iterate through every body, of course. Oops, I don't want to do that. There we go. I'm iterating through every rigid body. And here I'm gonna get the bounding box. Okay, so let bounding box equals to this dot rigid bodies dot shape, or we can say also get shape, and then bounding box. There we go. Then I'm gonna have, I will create some variables called left. This will be bounding box dot top left dot x. So we're gonna just get our most left side, most right side, most top side, and most, well, not side, but most left value, and so on. Yeah, and the same thing for the right one. This is also bounding box, this time bottom right dot x. Then let top is equal to bounding box dot top left dot y. Then we have a bottom is equal to bounding box bottom right dot y. Okay. Yeah, and now we can say now we can calculate our index in the indices index for left, right, top, and bottom, and we're gonna do that yeah, like in the presentation I did in the last episode. except we're going to clamp the values between 0 and cell count x minus 1. So we're just going to clamp the values between 0, between the minimum and the maximum cell count on that x axis. So it's not, we're not going to have something like out of bounds exceptions. Also, that means the spatial grid is only available in this world. All right, and nowhere else. Well, I mean, in that canvas we defined. Okay, in the world size. World size is our canvas size, basically. Okay, so the cell index. The left cell index is. Let's start with the parsing first. Parse int. This is left divided by this dot cell size. Okay. Then of course all the other things for right, bottom, and top too. It's the exact same way. Right cell index is parse int right divided by this dot cell size. Then we have top cell ID, top cell index. Also parse int. This is top divided by this dot cell size. Then we have bottom cell index. It's also parse int, not a float. This is bottom divided by this dot cell size. Okay, now I'm gonna clamp these values. Though I think we first need to create such a method. And for this, I'm gonna create a new method in our math helper class. And here we can create a method called clamp. I'm gonna say it's small. Well, actually, I don't know. I kind of made a complete mixture about writing code here. Definitely, yeah, it's definitely. I think it definitely needs some improvements, but I guess for introduction to physics engine, it's fine. Then we have a parameter for number, a parameter for the minimum value, and a parameter for max value. And here we're going to return, if the number is greater than max, we're going to return the max value. If the number is smaller than the min value, we're going to return the min value. And we can do this by math min. And here math.max. There's the number, min, and here the max. That's our clamp value method. All right, now we can go back to the spatial grid. And we can use this method by saying math helper dot clamp. This is our number. This will be our min value, which is 0, and our max value is this dot cell count x minus 1. Okay, now we can do the same thing for the other methods. I'm just gonna copy that and hope I'm not gonna do any mistake. This is this dot cell count x minus 1, and the other things are cell count y. Okay, this dot cell count y minus 1, and here also 0, and this dot cell count y minus 1. Okay, now we have half of the code already. Now we're gonna iterate through the cells. I'm gonna say the x value is the left cell index, while x is smaller or equal to the right cell index, we gonna add to x1 per loop. Then we're gonna go in the y direction, so let y, oh I forgot the let here, alright, is equal to not 0, it's equal to stop cell index y, well, while the y value is smaller or equal to the bottom cell index, we're gonna increase the y value. And now we can calculate the cell index with our formula. And this is cell index is equal to x plus y times this dot cell count x. Now we have our cell index. Now we can say this dot cells with the cell index. Oops. Cell index. There we go. We're gonna push our current object, so this dot rigid body, at the position of the position of I of the index. And yeah, that's almost everything. We also need to add the cell index to the rigid bodies to cells, so our mapping. So this dot rigid bodies to cell I dot push cell index. There you go. And now we can also draw the occupied rectangles. Here, first I need to calculate a position again. So let position is equals to new vector 2. This is x times this dot cell size. It's the exact same thing we did. We drew our rectangles before. I'm gonna say here plus 5. Actually, I think I can just copy this line here. Yeah, I'm just gonna copy that, paste it in here, and instead of gray, I'm gonna say black. And I guess that's everything we need. I hope so. For sure, I made a mistake, but let's see. Then we can implement our get neighbor ridges method, and here we get our neighbor rigid bodies. We still iterate through. We're still iterating through our rigid bodies for updating, but we get our neighboring rigid bodies from neighbor cells from this method. And we can do this by saying, by creating a variable called occupied cells. And this will be this dot rigid bodies to cells. And here I'm gonna pass the rigid index. And here you can see this is the index of the rigid body. For example, the first rigid body we added to our list in our simulation class will have the index of 0. And if you go to the map bodies to cell method in this line here, rigid bodies to cell, we're doing the same thing. We are adding the rigid body, or actually the cell where this first rigid body is into, is registered. And yeah, so we can get the cell index from the rigid body, basically. And so we can do our neighbor checks and get the other rigid bodies from the cells. Yeah. In the get neighbor ridges, I'm gonna also add a new variable called neighbor rigid bodies. This will be an array because in these cells there might be more rigid bodies than just one. Yeah, then I have a for loop, and we are going to iterate through the occupied cells. Okay, so in this array there are all cells which are registered to one rigid body, to one bounding box. Okay, in this one we'll have an array with all the cells which have the rigid body of this index. Now we're gonna iterate through that and see if this occupied cell, if one of these occupied cells actually have another rigid body which isn't this one, okay, which isn't a other rigid body, and then we're gonna return then the other rigid bodies to do our collision checks. I hope that's a little bit clearer. Yeah, we're gonna iterate through the occupied cells. Then we're gonna get the index. So occupied cell index is occupied cells at current index. Then we get the actual cell. So we're gonna say this dot cells. Alright, our rigid bodies are registered in these cells, in this cell array. Then we're gonna say occupied cell index. Here we get in this cell there might be more rigid body than one, so we need to again iterate through that. So let j equal to 0 while j is smaller than cell.length, j plus plus. And here we're gonna retrieve our Ricci in cell. There we go, Ricci in cell is equal to cell j. And here I'm gonna check if this rigid body is a other rigid body in the cell, okay? If this rigid body here is not the same rigid body like in cell, then I'm gonna say the neighbor rigid bodies dot push. So we're gonna push the other rigid body into the neighbor array, and then we can do the collision check with our neighboring rigid body, okay? And here I can say return, of course, rigid bodies. All right. Okay. I think I made a small mistake. There's a small typo. That must be rigid body. And also, I don't know why I did this. I totally forgot um, the for loop, the if I is smaller than occupied cells dot length. Okay, and I think that's everything we need. Now we can go back to the simulation and add our improvement slash optimization. For this, I'm gonna say, well, first I'm gonna retrieve the rigid body A. So let rigid A is this dot rigid bodies. Then I'm gonna get the neighbors from these rigid bodies. So neighbor rigid bodies is equal to this dot grid dot get neighbor rigids. This is with the index and then rigid A. Okay, then we have the neighbor ones. And what we are doing now is we are iterating instead through the whole list again. We're going to use this list with this rigid bodies, and we're going to iterate through this list instead. And here I'm going to remove this one. We also don't need this check anymore. We can remove this check too. There we go. I think I can remove this one. Nah, I just let it there. Yeah. I think actually, yeah, no, it should work. All right. Yeah, I think now we can go back to the browser and see if it's working. 1 second though, I forgot something. We need to check. We need to change this one and this for loop here, so that we are using the right, uh, the right list. Okay, so we're iterating through the list of the neighbors. I removed the check if the rigid body is the same, because we did that in the grid right there. Yeah, I think we can try that out. I'm gonna refresh refresh the browser. Oh, and it seems like I did a small mistake. Simulation 64. What's wrong here? Okay, I'm gonna take a look. I'll be back in a second. All right. Yeah, I'm not quite sure what was the mistake. I think it was a small typo somewhere around here. I copied it and tried things out with my implementation, um, with my source code, and I actually don't know. I think it was a small typo somewhere there, because I can't reproduce that error anymore. So make sure everything here is exactly the same like in your code, or look at my GitHub page. It should work there too. Okay. Yeah, let's go back to the browser. First I'm gonna change the solver iterations to 5. This episode is really, really long already. I wanna change another thing. I want that we're not gonna have a rectangle here anymore, because I want it to look like there are a lot of bodies with a working collision. So I'm gonna say a new circle. New circle. With a new position, new vector. Vector 2, x and y plus top offset. And then a radius of box size divided by 2 with a mass of 1. Yeah, go back to the browser, refresh. There are our circles now. And yeah, we should deactivate our console log here in our collision detection. Where is it? Collision detection 10. Okay, didn't found it till now. I'm in the collision manifold, of course. Yeah, there you go. Remove this one, refresh. Oh, okay. 1 second. All right, refresh, and there we go. We have our small simulation. Now, the really last thing, I'm gonna increase the pyramid to stress test our new performance optimizations. I'm gonna say iterations 35. The box size will be 20. Save. Yeah, I changed these two values to 20 and 35. Go back to the browser, save and refresh. And refresh. Oh no. There we go. There's our optimized simulation. Awesome. Yeah, sorry for the length of this episode. This is now almost 50 minutes, 46. In the next episode, we're going to simplify our spatial partitioning. We're going to add a new method. This will be spatial hashing. This is going to be easier because the mapping is just really simple with a simple formula, and we don't use that much methods. Also, we are not restricting ourselves to just our world size. This will work basically unlimited, or we're gonna have an almost unlimited size of cells. So we don't need the bounding boxes anymore. We can do then a neighbor search for, I don't know, the whole depending on how much numbers we have for integers and so on. Yeah. I guess that's it now. Again, sorry for the sorry for the length of this episode. The next one will be shorter. All right, then. See you there. Bye bye.